In this video, I will explain you force between two current carrying conductors. Let's say current of I1 is passing through this conductor and current of I2 is passing through this conductor. Now, we have learned in the previous lectures that when a current carrying conductor of length L is kept in a magnetic field of B, magnetic field is B, say for example. Now, what is the net force exerted on the conductor by the magnetic field? That is F is equal to I into L cross B. Right. So here in this case, I can use Fleming's left hand rule. See, this current and magnetic field is perpendicular to each other. So this one. So force will be in this direction. So when there are two conductors sending current in two different directions, but here it is the same direction, how will one be able to exert force on other? Reason is very simple. When current is passing through this one, it will be creating magnetic field around it, circular magnetic field. Now see, this is right hand rule. Here into, here coming out. So magnetic field lines will be there. So this one like this way. Magnetic field will be there around this. Now at this position, let's say this is at a distance of df away from the conductor. At this position, it will be exerting a magnetic field, right? How to get the value? We know that magnetic field created by a conductor is equal to mu 0 I by 2 pi into r. So here it is d. So that is magnetic field created by first coil on 2. So on 2, the magnetic field created by 1. So 1 is the cause here, 2 is the place where we are finding the magnetic field. So on 2, the magnetic field exerted by the current carrying element 1 is equal to this. So magnetic field of this at this position, simply. Okay, now with this magnetic field, it will be exerting a force on 2 in a direction. We will see the direction, which direction it is. So what is the direction of magnetic field? This one at this position into, right? Now current is going in this direction. So current, magnetic field, there will be a force here. What is the reason? This exert a magnetic field here at this position, and that magnetic field is exerting a force on this conductor. So this is the magnetic field. So force on 2 by 1, how to get the value? On 2 by 1 is equal to IL cross B. So anyway, magnetic field is into, current is in this way. So sin theta is sin 91. So it is basically I into L into B. So I into L into, so on 2 by 1, right? So we have to find, substitute the value of magnetic field created by 1 on 2. That is this one. 1 on 2. Mu 0 I by 2 pi t. So that is the total force. I am going to define a new quantity, force per unit length. So F21 divided by, one more thing, just a second. Now I2 is current passing through this one, right? So I2 into L, B is nothing but 2 on 2 by 1. Okay, so on 2 by 1, here magnetic field is created by this one, right? So here I should keep I1. So I1 means, if I see I1 here, means it is magnetic field created by I1. Now that magnetic field is exerting a force on I2. Okay, so this will be I2, this will be I1. So length I'll keep here. So what is the equation? Mu 0 I1 I2 divided by 2 pi r or d. So here it is, I'm going to use it as t. So what is this value? Force exerted by 2 on, sorry, by 1 on 2. I'll repeat it. Force exerted by 1 on 2 per unit length. So the force exerted on 2 by 1. The reason is 1. exerting on which object, which current carrying conductor? On 2. So force exerted on 2 by 1 per unit length is equal to mu 0 into I1 I2 divided by 2 pi d. Okay, so this is 2 pi distance in between them. This is force per unit length. This one is very important. Similarly, if you are finding the value of F12, so I1 and I2 will be just inverse. So the equation will be still the same, mu 0 into I2 I1 divided by 2 pi into d. So it's the same thing. So I can say that F12 is equal to F21. You can check it from your end. So force exerted by, what is F21? On 2 by 1. What is F12? On 1 by 2. See, here the reason is very important. Why it is exerting a force on this? This will be creating a magnetic field here. Now see, this current carrying conductor is placed in a magnetic field. That is the reason for the force here. Okay. Now what is the direction of force? It is inward here. Now with respect to this, we will see what is the direction of force. Right hand thumb rule. Current carrying conductor I2. So I2 will create a magnetic field coming from the plane. So towards me. Now what is the direction of force? This is magnetic field. Current is in this direction. So magnetic field, this one, right? Yeah. See, current, magnetic field, force is in this direction. Now this exert a force on this in inward direction, and this exert a force on this in inward direction. So when the current are going in the same direction, it is force of attraction. They come closer. Now when the current is in reverse direction, that will be repelled. I'll repeat it. When it is in the same direction, they will attract. See, force are inward, attract. When they are in opposite direction, so let's say current I1 is in this direction and I2 is in this direction, they will repel each other. Okay, thank you.